Welcome to Digital Electronics, Chapter 1. In Chapter 1, we will be looking at the number codes, number systems, and codes. We will first need to understand why we need to do coding, and in order to do so, we will first look at what's the real world systems and versus that of the digital world. After which, once we have understood the differences between the real world and the virtual world, we will see the need to represent the real world quantities in some digital form. So the next part is to see how we can represent this digital quantities in represent this real world digital quantities in the digital world. And finally, we will take a quick look at other digital encoding systems which represents the other real world quantities. Okay, so let's start with the real world. Let's compare what's in the real world versus that of the digital world. So let's see what's the differences between the real world and the virtual world. In the real world, the most items are measured in analog, right? Things like your height, your weight, temperature, these are all analog values. What do we mean by analog? They occur as a continuum of values. Okay, that means that it is not the values are continuous. It doesn't occurs in discrete unique quantities. So, for example, your height, your height can be measured in terms of, well, let's say, from the 1 meter to 2.5 meters, uh, to the closest millimeter if you want, and if you want even close, if you want even more accurate, if you want to be closest micrometer, that may be possible too. So in analog world, it's a continuum of values. In the virtual world, uh, things are represented digitally. So it's basically analog in the real world versus digital in the virtual world. And what we mean by digital, basically, quantities are represented by uh, discrete values. Okay, so for example, the some quantity can be represented by the value of 1 or 0. There's no such, and there's no other values in between. So this 1 and 0 are discrete quantities. Unlike in the case of analog, between a value of, let's say, 0 and 1, there are still other numbers in between, like 1.5, 1.25, 1.2, 1.025, and so forth. So there's a continuum of values between 0 and 1. So graphically, how would that be represented? Uh, let's look at this. So in the analog, an analog value would be represented by this continuous uh, line over time. In the discrete world, you see that the values, you see jumps in values. For example, 0 to 2 here. This is because there is no other quantity that can be represented in between. All right, the smallest step here is from is from this value to the next, nothing else in between. So this this is how a digital signal may be represented. The So some real life examples and comparison of digital and analog. You may be familiar with the speedometer in a car. So you probably have seen this in most car gauges. You have analog speedometer. This needle here moves continuous over a continuous continuum of values from 0 to 220 kilometers per hour. However, in the digital speedometer, as you will see shortly, uh, in this case, the speedometer will indicate only a whole number increase in speed, but nothing in between. So in this case, 188, 189, 190 kilometers per hour, etc. Okay, so having understood what the real world, how the real world quantities are represented, and how virtual world quantities are represented, we need a way of representing these analog signals, which are in the real world, to something digital so that it can be processed the, by our computers and microprocessors. So, okay, so such a system exists. The Take, for example, in the analog world, we have a microphone which picks up analog signals, and this microphone needs to go through an analog to digital converter so that you have the after the conversion you have digital values, discrete values here, and this goes into a digital system like a microprocessor or DSP so that we can process the signal. And after processing, uh, we output the quantity the quantity that is desired. For example, in this case, we might want to highlight the sound of the guitar from the background noise. So in our digital system, it will be able to pick up the music from the guitar and then reduce or filter off the the background noise so that coming out from the digital system we hear only the guitar. So then this, however, this digital representation cannot be interpreted by the human ear. It needs to go through a digital to analog converter so that you again have analog signals coming out from this point and passing through a speaker. You will hear the familiar music from a guitar. All right, we will be referring to this block diagram every now and then. The This block diagram form the basis of analog to digital conversion and digital to analog conversion. All right, in the first chapter, we will be focusing on how we can convert, we can we can represent this analog signals in the digital form, and subsequently we'll see how we can design simple digital systems to process some of this digital information.